And we're back to Learning Math with Kristen. So, what is a measure of central tendency? A measure of central tendency, these are numbers that describe what is average or typical of the distribution. And you can think of this value as where the middle of a distribution lies. And we use a lot of different, three main different types of measures of central tendency to sort of assess what our distribution looks like. Now, you might be thinking to yourself, what is a distribution? So, a distribution, right, we can think of it as, right, the range of where all things can occur. So if this is, right, this is going to be a graph maybe of, average SAT scores. So, right, we have all of our possible scores. Let's see, what does it go up to now? It used to be 1,200, now it's 20, what is it? No, it used to be 1,600, now it's 2,400. Right, so number of people and scores. Right, so if we have our nice little distribution chart here of average SAT scores, all right, we are going to see that, right, all of the number of people, right, and so if that is 0, 1, 2, 3, 4, 5, 6, right, all of the people over here, where this happens to be the highest means that that is the most number of people, right, right here, right, and so this is going to be really low numbers of people on either side, right, and folks tend to cluster around the middle. This is what we call a normal distribution or a bell curve, right? You want it to look kind of like a bell. And so when we talk about distribution, we're really just talking about how are these variables, how are the values of this variable, what do they look like? How are they distributed? Are they evenly distributed? Do they cluster around one thing or another? Are they going up positively? Are they going down positive or negatively? What does it look like, right? That's what we mean by distribution. And so again, we have our three measures of central tendency. They are mode, which is the most common score, median, which is the score of the middle case, and mean is the average score. So we can use mode with all types of variables, nominal, ordinal, interval, ratio. However, we can only use median and mean with interval ratio and ordinal variables. Again, our mode is going to be the most common score. It can be used at all three, and it is most often used with nominal level variables because that's the only one we really have for nominal variables. And it tends to be sort of what tells us the least amount of information, especially when we can, especially if we have more things we can work with, like we can with our ordinal and interval ratio. So we frequently will only really see mode when it comes to nominal variables. You have to learn how to do it with all of them, obviously, but when it's actually used out in the wild, mode really only makes sense to use in terms of nominal variables if you've got other options. There are exceptions to this case. However, that's generally how you will see it used. And we refer to the value of a variable that is the mode as the modal value, right? So the number that appears most often is going to be sometimes referred to as the modal value, but right, it's the mode, just different ways to refer to things. So to find the mode, you will count the number of times each score occurred, and the score that occurred the most is most often the score that the score that occurs most often is the mode. If the variable is presented in a frequency distribution, then the mode is the largest category. If the variable is presented in a frequency polygon, which we'll talk about later, the mode is the highest peak. And if the variable is presented in a bar chart, the mode is the tallest bar. Bar charts often make sense for figuring out the mode. In the distribution I just showed you, right, that I made up of SAT scores, again, right, our mode is going to be here if this is how many people earned that score, right? The number that occurred most is going to be right there, right, because that makes sense. So finding the mode, number of people, the opinion question is people should live together before marriage. 864 people agreed, 227 people said neutral, and 374 people said they disagreed. What's the mode? Agree, because that is the number that is the answer that occurred most frequently. Right, super easy. Again, when we look at bar charts, right, bar charts are really convenient ways to represent a lot of different types of data, but it's really easy to tell what the mode is when it comes to bar charts because it's the one that has the most responses. Super easy, right? So that's the mode. And next up, we have our median. The median is the score that divides the distribution into two equal parts so that half the cases are above it and half are below it. The median is the middle score or the average of middle scores in a distribution. So what do I mean by that? We'll see in just a second. Can be used with variables measured at the ordinal or interval ratio levels. Remember, again, how do you split what's the middle of Republican and Democrat and Independent? You can't really do that because there's no order, there's no rank. It doesn't make sense to do that. But we can do that with ordinal or interval ratio levels. And it can also be found using the cumulative percent on a frequency table. So going back to this one here. Nope, that's not the right direction. Whoop. Whoa, nope. Okay, we'll get there in a minute. What is happening? All right, so to find the median, right, we are going to arrange our cases from high to low, and we are going to find the middle case. An easy way to figure out what's going on is to figure out if n is odd, right, the number of people in our data or the number of responses in our data. If n is odd, then the median score is the score of the middle case. But if n is even, then the median is the average of the scores of the two middle cases, right? So if I ask 5 people, right, what their GPA is, right, I'm going to get rid of number 1 and number 5. I'm going to get rid of number 2 and number 4, and then number 3 is going to be the middle one, right? Let's do it. Let's do it with my hands, and I'll flip you guys off at the end, right? I'm going to get rid of 1. I'm going to get rid of 5. I'm going to get rid of 2, and I'm going to get rid of 4. And then 3 is going to be the middle case. However, if I have 6, right, and I get rid of the highest and I get rid of the lowest, this is hard, and then I get rid of the next 2, then I have these 2 left, and I have to split the difference, right? So if n is even, I have to get the middle score or the average of these 2 here in the middle. So finding the median. I have 7 cities here listed, right, based on their robbery rate. And so these are the number of robberies that occurred per, right, based on the number of people. Again, it's a little bit sketchy, but we use rates all the time, especially in criminology. And when it comes to crime, you see it in health a lot too. But it's not really accounting for how many, right, did robberies happen to the same person, right? Or, right, just to certain people. We talked a little bit about how rates can be difficult, but we also still have to work within them because lots of people still use them. So we have our robbery rate for 7 cities. I have organized them right by the rate, right, highest to lowest. And so to find the median, right, I'm going to take off the highest one, take off the lowest one, take off the next highest one, take off the next lowest one. And it's going to mean that San Francisco here is going to be falling in the middle. Right, again, if you organize it right by in a frequency table like this, pretty easy to find the middle variable. So San Francisco has the median out of these 7 cities with a robbery rate of 444.9. Now, how would this change if we added an 8th case? So I'm going to add in San Diego with a robbery rate of 145.3. Drastically lower than the others, and it is going to make it so that I now have an n of 8, which means that I am no longer just able to find the middle case super easy. So now that there are 2, why did I go that way? Now that there are 2, I am going to take the average of the scores of the 2 middle cases, right, being San Francisco 444.9 plus Los Angeles 420.2 divided by 2. Right, taking the average of those, and that is going to give me 432.55. So the median now is not a number that is on the chart, but it is the median number of robbery rates for these now 8 cities. So if we have the, what is the median for this hypothetical distribution? Hang on. So if I ask you to find the median for this hypothetical distribution, you can do this in a couple different ways. So you could write out very high 5 times, high 7 times, moderate 6 times, low 7 times, very low 3 times, and just take off the top, take off the bottom, take off the top, take off the bottom until you get to the middle. But if you have, 28 is a lot to do that with to begin with. If you have a study with like 300 people, you don't want to have to do that. So there's multiple ways to do this. You can divide 28 by 2, which tells you 14. And then you're going to have to take 14 and 50, the 14th and 15th case to find the median. Or you can find the cumulative percent. So while this chart doesn't give you the cumulative percent, a lot of charts will give you at least the percent. So I made up a chart. So, all right. So we have very high is 5 cases, which is 18% of the total number 28, which means our cumulative percent is 18. High is 7, which is 25%. You add that 25 to 18 and you get 43%. So let's stop for a second. 43% of all answers were either high or very high, which means that because moderate is 21%, that we now see, right, we add 21 to 43, 64% of folks are in this moderate category, which means that's where 50 falls, right? So 50% is what we're looking for when it comes to median. And so this is how a cumulative percent can help you find the median of the distribution. Right, so if they already give you the percents or the cumulative percents, you can use this to sort of skip having to do anything else. But if we think that, right, we know it's between 14th and 15th case, we can add up 5 plus 7, that's 12. So that means, right, plus 6 is going to give us 18, which means that the median is going to fall within moderate. You can see the other ones that I did here, but that's not going to matter so much, right? Because our cumulative percent is going to easily tell us here that the moderate is where the median is, as well as figuring out where the 14th and 15th cases are. All right, that is the median. So coming up next is the mean. I'm going to talk about it a little bit here, but I am going to break this up into another video just because we're going to spend more time on mean than on the other two because there is math involved. I'm going to go back to that sigma symbol, talk about some formulas and things like that. So I'm going to introduce the mean here, but then I'm going to stop it and we'll do more calculative videos after this. So the mean is the average score of the distribution. And it, again, was going to require variables measured at the interval ratio level or at the dichotomous dummy level. It cannot be used for nominal or ordinal level variables unless they are converted to dummy variables, which I will explain how to do. But again, this should make sense because what is the average like ranking, right? If very high, high, average, low, very low. Hard to find a mean for that. So we have to do some work to them in order to figure out means. But right, just think about it for right now until we get to the dummy section. Let's just think of it as interval ratio variables. And mean is pretty easy, right? You should know how to do this. If you have to add up all of the scores and then divide that by the number of scores possible. So we are I'm going to pause here, start another video where we talk about this sigma symbol and why it is helpful when it comes to doing formulas.